So here we have if e raised to power 2s plus 3y is equals to s square minus ln xy cube. So we want to find the y ds. Yeah. So this is implicit differentiation. So now to differentiate implicit, so take notes. If I want to differentiate e raised to power 2s, for example, this will be 2. That is, I'll first differentiate what I have here. So that will be 2. Then you will rewrite everything complete. So that will be 2 e raised to power 2s. So it is this technique that I will use to differentiate this. And if you differentiate log x to base e, so that will be 1 over x. So these are the techniques to use here. And I've done video on calculus. You can watch the calculus video. So now let's start. So differentiate this. Everything is like saying d ds of e raised to power 2s plus 3y equals d ds of x square minus d ds of ln sy cube. Meaning we want to differentiate everything here one by one. So but before we differentiate, this ln is like saying log. So if I say ln ab is the same thing as ln a plus ln b, so I can actually split that so that I can have d ds of e raised to power 2s plus 3y equals d ds of s square minus d ds, then I have ln x plus ln y cube. So because this expression here is the same thing as ln sy cube, so in log, so this is the same thing as so this 3 can go to the back of your y, so that means this can be ln x plus 3 ln y. So now this the s can open the bracket, so I can have d ds. So I have not differentiate d ds of e raised to power 2s plus 3y is equals to d ds of s square minus d ds of ln s minus d ds of 3 ln y. So that is this there will open the bracket there. So I can now differentiate everything now. So differentiate here, start from here. So differentiate 2x, so we get 2. Differentiate 3y, you get 3. But anytime you differentiate y, just add the y the s, because we are differentiating with respect to x. So if you differentiate y, then add the y the s. So if you watch my video on implicit, so you know how we get the dy dx. But for now, know that anytime you differentiate y, you should always have the y dx at the back. So now differentiate 2x, you get 2. Differentiate 3y, you get 3. But add the y dx because it's y. So rewrite everything here complete. So write everything. So that means we have differentiate this part. So it's equal to, now differentiate s square, that is 2s. Let me see if it can contain this space. That is the ds of s square is 2s. Now differentiate ln s, that is 1 over s. Then minus again, differentiate ln y, that is 1 over y. But I have 3, so that will be 3 over y dy over ds. So I have 3 at the back. So but if I differentiate only ln y, that is 1 over y dy ds. So if you put the 3, that is 3 over y. So that means we have differentiate like this. So now use this e raised to power this to expand the brackets here. So we are going to get, so this will be 2 e raised to power 2s plus 3y, that is 2 times everything here. Again 3 dy dx times everything again. So we open the bracket. So plus 3 e raised to power 2s plus 3y dy over ds. So is equals to 2s minus 1 over s minus 3 over y dy over ds. Now take all those ones with dy ds together. So we have 3 e raised to power 2s plus 3y dy over ds plus 3 over y dy over ds. You know it's minus here. So by the time you take it to this side, it will become plus. So it will be equals to, so I have 2s minus 1 over s. So take this one also to the other side. So that will be minus 2e raised to power 2s plus 3y. Like that. So we bring the y ds to one side. So the y ds is common to both sides. So this will becomes 3 e raised to power 2s plus 3y, then plus 3 over y dy over ds. So it's equal to everything here. So it's equals to this. So that means our next step now will be dy ds will be equals to all this. So everything there divided by, as in everything here divided by this. You know, we are looking for the y ds. So divided by 3 e raised to power 2s plus 3y, then plus 3 over y. So that is the final answer. So you found the y ds. So the only thing you can do here again is if you find the LCM. So maybe you find the LCM, but if you stop here, no problem. But if you find the LCM, for example, let's say We want to find the LCM. If you stop there, no problem. I can stop here and I can just say the YDS is equals, so the up one, let's say this is the up one, the numerator here. So find the LCM. So this will be over 1, all these two will be over 1. So that means the LCM is x there. So if LCM is x, so this will be over 1 over 1. So that means this will be 2x squared minus 1 minus 2x e raised to power 2x plus 3y divided by the LCM of the down one is y. So that will be 3y e raised to power 2x plus 3y plus 3. So like that. Now if division change to times, so we have the YDS is equals to 2x squared minus 1 minus 2x e raised to power 2x plus 3y divided by x times y over 3y e raised to power 2x plus 3y plus 3. So that is, this will go up, this will come down like that. So now this will be the y over the s will be equals to y bracket 2x squared minus 1 minus 2x e raised to power 2x plus 3y divided by x brackets 3y e raised to power 2x plus 3y plus 3. So you can also stop here. And if you like, you can use the y to open bracket anyhow. So if you stop here, no problem, still get your answer. Or if you simplify further to this place, still the same. Or if you like, use the y to open the brackets to do it to last edge, so still the same. So that means if you stop here, that is your answer. Or if you continue this way, so if you still continue, that is the y will open bracket, so this will be 2s square y minus y minus 2sy 2sy e raised to power 2s plus 3y over the s will open bracket here too, 3sy e raised to power 2x plus 3y then plus 3s. So that means we've simplified everything. Yeah, so that's the answer. Or you stop in the other one.